Let's continue our presentation, and this is part 2. I'm going to give you here a quick introduction about the subjects that we are going to discuss today. First, we will try to understand the connection points, connection dots, connection subjects between our operation/maintenance experience and reliability program. Second, we will try to define reliability program, reliability report sections. And third, we will see high-level general airline reliability program, reliability report template. Let's start our presentation. First, Aviation Authorities document, and I'm talking here about United States Aviation Authorities, and document related to the maintenance requirements maintenance program was issued in 1930, and document name was Aeronautical Bulletin 7E. 1968, industry started maintenance steering group. Group was created to form decision logics, procedures, processes to develop maintenance scheduled requirements tasks. So far, as you can see, there are 3 revisions of the decision logics algorithm. Revision 1, MSG1, was issued in 1968, MSG2 1970, and MSG3 1980. Now you can ask the question, is there only tool MSG analysis that manufacturer uses to develop maintenance requirement maintenance program? Answer is no, but in today's our presentation we are going to discuss about reliability program for maintenance program that was developed based on MSG3 logic. How it works? Let me give you here general high-level explanation. So we have 2 parts in this business, right? We have manufacturer side, we have operator. Let's start from manufacturer side. From manufacturer side, we have different groups. We have part designers, system developers, product builders. What is our product? Our end product? Our end product is aircraft. Aircraft has a lot of requirements, and following are one of the main requirements. So aircraft should be safe, reliable, and airworthy. What does it mean, these requirements for our groups? It means that they have to build, they have to design, they have to develop the aircraft, this product, the appropriate level of safety, reliability, and airworthiness. This is one part of the story. Second part is that since these groups are developers, builders, designers, they have to also develop requirements for real life. They have to develop operation/maintenance requirements. And what they are doing, they are taking different types of analysis. They are taking MSG analysis, safety analysis, reliability analysis, airworthiness analysis, human engineering analysis, maintainability analysis, and applying to the product, applying to the aircraft, starting from the tail, ending to the nose, starting on aircraft level, system level, subsystem level, part level, item level. When all these requirements, operation/maintenance requirements, are ready, this information manufacturer delivers with the aircraft to the operator. Now, after all papers are signed and product and documents are delivered, it is operator's responsibility to maintain in real life the product of this our aircraft minimum designed level of safety, reliability, and airworthiness. It is an operator's responsibility. Okay? So product should be safe, reliable, and airworthy during real life, during operation. And what operator is doing? Operator takes all this information. They are building organizational structure, maintenance structure, operational system, maintenance system, logistical structure, logistical system. They are developing maintenance program, tasks, intervals, etc., etc., etc. Here's an interesting story. One thing is when we design something, right? When we develop something, when we build something. Another thing is when it goes to the real life. Unfortunately, it's not always what we designed. It not always behaves the way what we, let me put this, what we expected, right? And we need to put in place system that helps us to assess our product mechanical performance. We need to put in place system that helps us to measure effectiveness of our operation/maintenance requirements maintenance system. And the core part, main part, major part of the system is reliability program. Reliability program helps us to assess product mechanical performance. Reliability program helps us to measure effectiveness of our operation/maintenance system maintenance requirements. Now, how we can assess our product mechanical performance, how we can measure effectiveness of our system, there are different ways. First, we can assess it, we can measure it case by case. We call it event-oriented reliability program. As I said, this is the reliability program is the part or main part, core part of the system, right? So how it works, let me give you here explanation. Let's say we have an event, we have occurrence. Let's say we have a engine high vibration, right? So we have one event, one occurrence. So when we have event-oriented reliability program, this one occurrence, one event is enough. So we're going to fix the problem first, right? Then we're going to try to understand what happened. We're going to do root cause analysis. And what we are doing actually, we're taking all this knowledge, all these solutions, we are implementing into our system for all our aircraft. So for event-oriented reliability program, one occurrence, one event is enough to initiate corrective action for all aircraft, for all systems. Okay? And the second part, statistical oriented reliability program. I'm going to give you here an explanation. And let's go back to part 1 when we had this scenario 2 discussion about DC batteries. What we said, we had 15 unscheduled removals, right? So actually what we are doing, we are doing statistical / mathematical analysis. We want to understand where we are. By the way, we are talking now here about reliability program methodologies, right? So we need to understand, when we have these 15 unscheduled removals, we need to understand where we are, what we're going to do. That brings us to the next level of our reliability program methodology, which is alert type, non-alert type. From alert type perspective, what we are doing actually, we have to ask the question. We are questioning this number, alert levels. It is too high or not too high to initiate corrective action for all aircraft, to implement this corrective action for all our systems that maintains minimum design level safety, reliability, and airworthiness. So we need to answer this question. I put here determine alert levels and determine alert levels and target levels. I'm repeating, but this is very important to understand. We need to understand if these 15 number, right? We said we have 15 unscheduled removals. Is too high or not too high to initiate corrective actions, to implement corrective actions for all our aircraft, for all our system. Call it alert type reliability program, and here you can see non-alert type. I think it is clear, which one event, one occurrence initiates a corrective action for all aircraft, for all system. Okay? Now, to summarize this slide, let's answer the next question. What is the purpose of reliability program? And answer is, the purpose of reliability program is to ensure that the aircraft maintenance program tasks are effective and their periodicity is adequate. Reference. Number 1. Yes, Appendix 1 to MCMA 301-302. Number 2, FAA Advisory Circular 12017A. FAA Order 8900.1. FAA Advisory Circular 12122C. Number 3, Transport Canada AMA 571-101/1 and Transport Canada Advisory Circular 605002. Now we can use as reference 2, 3, 4, 5 more aviation authorities, airworthiness authorities requirements. But I can tell you right now that approximately 70%, 80% of requirements are similar. They're gonna be the same. Okay. For this reason, we're gonna use in our presentations, these 3 aviation authorities requirements as a reference. Quick notes here. First note is excuse me, general note. There is no unique method to develop reliability program. It depends on local aviation authorities requirements, operation maintenance environment, fleet size, airline maintenance business model. Let's say we have maintenance provider, operation maintenance experience. Reliability program is done in-house or third party. Let's say we have contractor, personnel, aircraft and system knowledge, qualified, non-qualified, types of approved maintenance program, etc., etc., etc. And note 2, it is more specific, related to our today's presentation, to our today's reliability program. So we are developing reliability program for next type of operation, for next type of airlines. Fleet size, minimum 5 aircraft, same type or more. Maintenance/operation data is sufficient, usually 2+ years. Reliability program is statistical type, alert type. It's very important. And definitely, as we already said, maintenance program is developed based on MSG3 logic. Now let's move to the next slide and try to understand our connection points between our maintenance/operation experience and reliability program. So everything starts from business. Business comes and tells us, hey, dear operation, let's say in December, we're going to fly from London to New York. We're going to have 20 flights. Just using here as example, 8 hours, right? So totally in December, our projection is 320 flight hours, 14 cycles. These numbers are goals for our flight department, for our operation department, ground department, maintenance department, aircraft support department. All these departments, whole airline works very hard to maintain these numbers. Works very hard to support these numbers. Okay, so now what information we're looking for from reliability, safety, airworthiness perspective? Definitely we are looking for, from these flight hours, information about mission interruption flight, mission interruption ground. From mission interruption flight, number 1, it is in flight shutdown. Engine in flight shutdown. Do you know what? If you open almost 100% aviation authorities, airworthiness authorities requirements, documents, number 1 requirement is going to be engine in flight shutdown. We have to report it, right? I think it is clear. No engine, no flight. Right? Next, ground turn back, rejected takeoff, and turn back, diversion, abnormal landing, emergency on the board, etc., etc., etc. What information we are looking for from mission interruption ground? Is delay, cancellation, AOG, technical auto service, etc., etc., etc. This is from flight operation side. Now, what about maintenance side? From maintenance side, we need to answer question. Why we are removing this part? What kind of maintenance we are doing? Why we are doing this maintenance? What types of maintenance we are doing? And here is the small list types of maintenance. So we have routine maintenance, scheduled maintenance, planned, unscheduled, and other types. What is the difference? Let me give you here another explanation. I'm going to use again scenario 2 from part 1. So we said we had 5 scheduled removals, DC battery, and 15 unscheduled. Let me explain what does it mean. So 5 scheduled removals means that we removed all these 5 items as per manufacturer MPD, MRB requirements, which was, if you remember, right, we said 3,000 flight hours, right? So all these 5 items we removed at 3,000 flight hours. What about unscheduled? Unfortunately, probably first one was removed. Well, let's assume here 2,000 flight hours, second one 2,300,